Alright, we're back and we're doing the second exponent video, and for this one we're going to talk about division extended. There's something else I want to talk about in division, I didn't really get to it, but there's a reason for that. So, before, let's just review, I said if we have a to the b divided by a to the c, it's equal to a to the b minus c. Now, that's obviously true, and we showed that was true in the last video, the last video or the first video. But what I want you to see is this. What if you had 6 squared divided by 6 to the 4th? Now you're probably going to say, oh, well, 4 minus 2 is 2, and that's certainly true, but what you really have is 6 to the 2 minus 4, which equals 6 to the negative 2. Well, that's certainly true, and that's certainly true, so let's see what that actually means. 6 squared divided by 6 to the 4th really means 6 times 6 divided by 6 times 6 times 6 times 6, which, as we said before, canceling out, leaves us with, now some people say, oh, well, 6 squared, and that's your answer. Well, that's not true, because when you simplify, don't forget, these actually become 1s. And 1 times 1 is 1 over 6 squared. Well, take a look at this. My argument was that 6 squared divided by 6 to the 4th is 6 to the negative 2, but I just showed you that it's equal to 1 over 6 squared. So, what I'm hoping you're going to realize is this. 6 to the negative 2 is really equal to 1 over 6 to the 2, right? 6 squared. This actually brings up another law, and this law is huge. It's actually super important. It says that a to the negative b, this is my a, this is my negative b, is equal to 1 over a to the positive b. Alright, so this is super important. Similarly, if you had 1 over a to the negative b, and you want to make this positive, the exponent, you can move it on up as a to the b. Alright, so these two are absolutely very important. Very important. I'm going to erase everything, so if you need to pause this to copy some things down, please do so now. Otherwise, say bye-bye. I'm erasing everything. And the reason why I'm erasing everything is because I'm going to do some work with what we were just talking about. But we're going to go back. We're going to go back to this red. I kind of like this red. So let's take a look here. Let's say I had, I'm going to make a little table. And one of my favorite sets of exponents, and I'm sorry that this table is kind of messy, but that's alright. If I really wanted to clean it up, I could, is the power of 2. Power of 10 is actually a good one as well, but I'm going to work with power of 2. So 2 to the first means 2, 2 to the second means 2 times 2, 2 to the third means 2 times 2 times 2, and 2 to the fourth means 2 times 2 times 2 times 2. Well, this is 2, this is 4, this is 8, and this is 16. Something that's a little bit harder to see is, what's the value of 2 to the 0? Well, if you take a look, each time I'm increasing the exponent by 1. Right? 2 to the 0, 2 to the 1, 2 to the 2 squared, 2 cubed, 2 to the 4th. But right here, I'm actually increasing by 2. Well, as I increase by 2, these are supposed to be arrows, I realize they don't look like anything. As I increase by 2, or by a power of 2, that would be the same as going backwards, dividing by 2. 16 divided by 2 is 8, 8 divided by 2 is 4, 4 divided by 2 is 2, 2 divided by 2 is 1. Whoa! Wait a second, so 2 to the 0 equals 1? Well, that's weird. Well, 4 minus 1 is 3, 3 minus 1 is 2, 2 minus 1 is 1, 1 minus 1 is 0, 0 minus 1 is negative 1, which is 2 to the negative 1. which we just said was 1 over 2 to the power of 1. And then we get 2 to the negative 2, which is 1 over 2 squared, or 1 over 4. Now you might be saying, well, that's wonderful and who cares? I'm going to show you something that's actually kind of neat. Check this out. This is I'm going to go out on a limb and say fascinating, although you might not think so. Here, whoa, what's going on here? Take a look at this. So we have 2 to the negative 1, 2 to the power of 1, but this is 1/2 and this is 2. Look at this, look at the denominator here and look at the number here. Oh, what's going to happen here? Whoa, oh my goodness. So we end up with 2 to the negative 2, and I'm going to start laughing because my wife is laughing at me. So 2 to the negative 2 gives you 1/4, but 2 squared gives you 4. So using that mentality, what do you think 2 to the negative 4th is going to be? Well, we know what 2 to the power of 4 is. We know that 2 to the power of 4 is 16. But remember, all we have to do is put it 1 over, and you get 1 over 16. That is wonderful. The other thing that I want you to realize is this. Yeah, this works for the power of 2. But if you change this to any power, we had changed these to all 3's. Whee! Look at that. The same exact thing would happen. The only difference is, I should have really not been so sloppy here. The only difference is everything would become 3's, but what you will realize when you sit down and actually crank out all the work is that you're going to get 3 squared, which is 1 over 9, 1 over 3, which is 1/3. This still becomes 1 because this is going to be 3. Oh, this is going to be 3 times 3. It's going to be 3 times 3 times 3. It's going to be 3 times 3 times 3 times 3. So this is going to be 3, 9, 27, then 81. And my big point in here is this right here. 3 to the 0 is going to equal 1. 2 to the 0 equals 1. So a to the 0 equals 1 if a does not equal 0. That's right. There is one exception. 0 to the 0 does not equal 1. Right? So that's the only exception. A to any number, negative 6,832 radical pi to the 0 still equals 1. Alright, that's it. That's the end of this video. Hope you enjoyed it.